let's look at section 6.6, where we want to consider a general factoring strategy. A polynomial is factored completely if it is written as the product of all prime polynomials. Here's the general strategy for factoring polynomials completely. Factor out the GCF if necessary. Sometimes there won't be a GCF, but if there is, you definitely want to factor that out first. That will make your factoring easier if the GCF is factored out first. Technically, it can be factored out last, but your work is easiest if that's done first. If the leading coefficient is negative, factor out a common factor with a negative coefficient. So it's always easiest to factor a polynomial that has a positive leading coefficient. If your polynomial doesn't have that, you can always factor out a negative GCF first, and then the polynomial that remains in parentheses will have a positive leading coefficient. Select a strategy based on the number of terms. If there are 2 terms, try to use one of the special factoring rules. If there are 3 terms, see if the trinomial is a perfect square trinomial. If so, factor using one of the special factor rules. If there are 4 or more terms, try factoring by grouping. Check to see if any factors can be factored again or further. Check each factor other than monomial factors to make sure they are prime. Check your answer by multiplication. Here's an example. If I want to factor w squared minus w plus 20 completely, I look at each term and observe that there is no common factor. The expression has 3 terms, so the first and last terms are not perfect squares. The first term is, but the last term isn't. They both would need to be for this to be one of our special forms. The leading factor has a coefficient of 1, so we need 2 factors whose product is negative 20 and whose sum is negative 1. Since b is negative 1, that's the coefficient of w. The factors will have opposite signs in this case. So whenever the factors need to multiply to give a negative, one of the factors is negative, the other is positive. So there are 3 options. Either I use 1 and negative 20, 2 and negative 10, or 4 and negative 5. But only, so I look at the sum, which needs to be negative 1, and only the last one, 4 and negative 5, add to give a negative 1. So this is the pair that are my factors. So w squared minus w plus 20 is w plus 4 times w minus 5. And then we want to take a minute and look, is w plus 4 prime? Is w minus 5 prime? The answer is yes, so the factorization is complete. And we can check this by multiplying it out. Using the distributive property twice, w times w is w squared. W times negative 5 is negative 5w. 4 times w is 4w. And 4 times negative 5 is minus 20. So this simplifies to w squared minus 20 minus w minus 20. And so it checks out to give the trinomial that I began with.